is not short on challenges. You don't have to look far to find them. There are 7 billion of us, and counting.
7 billion people who need homes, schools, hospitals, places to work, clean water, energy, security.
And each other. 7 billion people connected by roads, bridges, rails, airports, seaports, and a common desire to leave this world better than they found it.
It's one thing to imagine that world. AECOM was built to deliver it.
We are a global community working together to create new possibilities for the communities around us.
Different disciplines, different backgrounds, and different perspectives, connected by a common goal, solving our clients' most complex challenges.
We know that amazing things happen when we meet those challenges together. Our projects transform cities, develop economies, and protect environments.
We bring new life to the heart of a neighborhood.
We bridge the gap between what is and what can be.
We do what's never been done, so the world can learn what must be done.
Every day, we deliver new opportunities for clients and communities.
To help 7 billion people look forward to tomorrow.
We are AECOM, built to deliver a better world.
Thank you, everyone. Since AECOM is dominating this session with the 2 out of 3 presentations, we felt a 1-minute plug was appropriate. And truly in keeping and standing with our name, Building a Better Tomorrow, I'm going to speak about a project called the Dholera Special Investment Region. The Delhi-Mumbai Industrial Corridor is India's most ambitious industrial program. It's a corridor that's been designated by the government of India as the corridor that's going to house 7 brand new cities over the next 10 to 15 years. And this is primarily to increase the urbanization, and these are all going to be industrial townships. The concept of this corridor came about when the government of India and the government of Japan got together in 2007. And the genesis was the dedicated freight line between Delhi and Mumbai, and they designated a swath of land 300 kilometers to be called the industrial corridor. And Dholera is the first of the largest industrial townships that's going to get off the ground. It also fits in well with the India's strategy of increasing employment, becoming industrial, and considering that of the 1.2 billion people, only 300 million people live in urban cities today, and they're expecting another 300 million people to migrate to cities. This is an ambitious program, to say the least. So this is what Dholera looks like today. It's pretty barren, open. There is only one small community of the size of 5,000 called Dholera. It's a village, but there are scattered villages. On the right-hand side, you'll see the Google map that shows several scattered smaller villages with 3,000 to 5,000 population. But the total population of the 920 square kilometer of land that we have acquired and going to be working on, the total population is only about 32,000 people. But when it's transformed into a hustling, bustling, vibrant city, we really cannot call it a project anymore, because the magnitude and the scale that we are talking about, and just sitting in the back of the room there in the earlier presentation, a thought occurred to me, what is mega? I mean, mega can be in terms of size, complexity, never been done before. But in our case, it's really mega in all directions, because we're dealing with all the different trunk infrastructure components. We're dealing with size. We are spending over $100 billion in building these brand new cities. And we are, in fact, doing nation building. It's not just a city anymore. It's nation building exercise for us. So to start with, on the left-hand side, you see the map of Dholera. That's what ultimately it's going to look like. That's the Vision 2040. It's about 920 square kilometers. And to put that in perspective, that's larger than the size of the country of Singapore. Singapore is 670 square kilometers. And so we are about 920 square kilometer, although the constructible or the developable portion is about 500 or so square kilometers, because part of it is in the tidal zone. In order to create a strategy to grow a city, you really cannot construct that big a landmass. It takes a lot of money. You don't know where to focus. So we had a strategy, and if you go down to the extreme right-hand side, you see that small area called the activation area. So we have come up with a strategy to start building the city with a nucleus of 22 square kilometers. And that's what we call our activation area. We started with that, and you see the timeline. We've been working on this since 2009. Now, a lot of people ask us, why does it take so long to build a brand new city? Well, the answer is it has to go through a lot of processes. The first step is developing a master plan. That takes about a year and a half. It has to be notified. It has to be sanctioned. There are public hearings. You got to get the public involved. Then the next step is land acquisition. Land acquisition is not an easy process. It takes time to do land acquisition. And then finally, getting all the environmental clearances, which is a project of this magnitude. You can imagine the kind of documentation and the Four Seasons data that we have to collect. So all of that took time, and it took about 3 to 4 years for us to get through that process. At the end of that process, we started the design process. And AECOM, as a program manager, managed the entire show, right, from planning, design, through construction. We're going to do it through operations. Now, the design is almost complete, and we are here in November 2015. The tenders have been floated, and we hope to break ground on December 19th, 2015, when the Honorable Prime Minister is going to lay the foundation stone for our roads and services contract. And the first contract is valued at about $350 million. So that's what we start with. And then by 2019, all of the trunk infrastructure will be completed. Simultaneous to the construction, we are beginning to attract anchor tenants. We are doing extensive road shows. A program like this helps us get coverage. We present it to the Hanover World Fair, and that's where we attract the international clientele, because what we are truly building is a world-class industrial township. The business goals for this project are really unique, just as the magnitude and the scale of the complexity of this project is. First of all, is to create employment, because India is going through a phase of extreme industrialization. Like I mentioned, 300 million people are going to migrate to cities, and that's where the GDP growth is. So we have to create employment. When this township is completed in 2040, we hope to have 2 million people living in there and creating some 800,000 new jobs. And that's just the beginning, because once you start multiplying that, the multiplier effect is going to be humongous. The second major goal is to build a sustainable smart city. Well, what does that really mean? In the old days, the industrial townships were really industrial. Those of you who have seen the industrialization in Germany or parts of Europe, we are trying to accommodate and be smart, in the sense the definition of smartness is make it so user-friendly that people don't think it's an industrial township, that it's really a city that they want to live in. So we have open spaces, parks and recreation. We've got the lifestyle, pedestrian lifestyle. We will have technology to make sure that they have information at their fingertips so they can make all the right decisions, whether it's transportation related, water utilities related, power related. So all of that information, all of that technology is embedded within our design, and that's what we're going to carry through our entire execution. The third is we align extremely well with the Make in India campaign. India, like I said, is attracting a lot of foreign investors. They have relaxed the FDI regulations. We are attracting major industrial houses. And a city like this is giving rise to opportunities to industrial houses who want to come and relocate to India. Defense. We are looking at defense, MRO, aviation, and heavy engineering are the 4 major sectors we are looking at, primarily because these sectors are extremely land intensive. And we have large swaths of land we can offer at very reasonable prices, and the opportunity for upscale benefits is humongous. And then finally, we are a part of the Digital India campaign. Everything in India from now on, as you know, India is propelled into the digital technology age, and our cities are also going to be like that. So we are becoming a role model to make the cities grow in India. So when you look at the complexity that we're dealing with, it's not just one infrastructure project we're building a massive scale. I mean, every single project I saw this morning had one infrastructure component, whether it's rail, water, sewer, transport, but we really have technically all of these across us, and then we are tying ourselves with the growth of India and the future of India. So at this point, I'd like to introduce Jay. By the way, I forgot to introduce myself. My name is Jag Salgaonkar. I'm the program director. I'm the senior VP with AECOM India, and I lead the Smart Cities and the Mega Projects Initiative in India, Southeast Asia. Jay.
Thank you, Jagdish. I'll straight away get into challenges. So Jagdish mentioned about the scope of the project. So from an engineering standpoint and from a time scale standpoint, there are lots of challenges. But today we are going to focus on some of the engineering challenges and how we leverage technology to overcome some of the integration and interoperability challenges. And starting with the scale of the project, it's like this is what the federation looks like. So it had every possible infrastructure in there. You talk about road, bridges, railways, water networks, storm sewer buildings, and all the existing landmass available. So when we started looking at the technology roadmap, we had to consider each of these aspect of the design, and then also consider all the stakeholders. So being a program manager, we had to manage our clients, which again is not one, but there are several kinds: the central government, the state government bodies, as well as our consultants. So there are 8 different consultants working on design. So our job was to manage that and manage the information which they created. And when we get into the different aspects of infrastructure, each of them had their own challenges. Like transportation, it needs to be an intelligent transport system, not just a road network or a rail network, but an intelligent transport system. So that intelligence had to be built into the design and needed a technology platform to do that. Again, from a water network system, it's meant to be a smart water network wherein the objective is that the citizens get 24/7 water supply, which to the Western world might be norm, but in that part of the world, which is a big thing. And one of the other objective is to ensure, the design ensures that the non-revenue water is less than 5%. So the efficiency required in the network is very high. So there were a lot of engineering challenges in terms of design of that network. Again, from a wastewater network, it is meant that we recycle 100% of the water and reproduce and do effluent management treatment. In phase 1, it will be 100% recycle, and then there'll be intelligent components which had to be factored in the design so that in future, when the next phases kick off, we can leverage that. Again, from a stormwater network standpoint, it's the terrain is pretty flat, and so designing a stormwater network was a big challenge. And various iterations were done to decide whether we should go with traditional concrete drains or use something like a bioswale, which is more sustainable, environment friendly. And those engineering iterations helped to decide that the bioswales were better, which helped the client and the project saved millions of dollars and make it more environment friendly and save time and money in terms of doing those iterations as well. Again, solid waste management, the objective is that 100% of the solid waste is collected and processed, and then in future it has to be planned so that you can generate energy from the solid waste. So all these components of a smart city had to be built in. Again, from a power standpoint, 24/7 power for and reliable power is one of the key components to get the industrial town running, and all the intelligent design required in there. Now, again, it's a smart city, right? So it needed all the ICT design in place to enable the smart component of there, whether it's for transportation or the economy or utilities. And one of the key differentiator was that the government had mandated use of BIM and GIS as well as e-governance. So when we started off the project, we had to plan for each of these components and start building the information model from day one so that we can sustain it through, let's say, 2040 and get it into the city management later on. Again, plan, control, command center, which would manage the entire city and all the information within that city. So just to sum up, when you look at the activation area, the numbers speak in itself. So although it's 22.5 square kilometer, it has 70 plus kilometers of road design, 6 kilometers of drainage, 400 kilometers of utilities, plus the power transmission lines and several other infrastructure. So all of this infrastructure had to be designed on the ground. From a technology standpoint, because e-governance was mandated and BIM was mandated, we had to look at various aspects of technology. So we implemented a comprehensive GIS system. We also are building a comprehensive BIM process and a system plus integrated with the document control and project information system and project collaboration system. So all of these systems had to coexist for us to leverage the information and to collate information together. So again, when you look at that information model, again, this is what the model federation had to be. Each of these infrastructure was designed by a different engineer, based in different offices. All of that had to be connected together through a collaborative environment and a different organization. So we had to create a workflow for the information flow, wherein the engineer would use Bentley and other technologies to create the engineering analysis, and then that analysis model would then be used. We used iModels to create the 3D models from the analysis. We also use the same information model to create GIS information sources. So multiple information sources were created out of the same engineering model, as well as to communicate and help clients sell the project. We created visualization to do that as well. And because it's a iterative process, in 2 years' time, it went through at least 10 to 12 iterations. So there's a significant amount of churning back between the design and issues and things which had to be done. Now, I'll get my colleague Surya to talk about some of the applications.
Thank you, Jugal. And so you can imagine about the scale of projects and all about the challenges, right? So I'll talk about to manage the informations. These are the informations about satellite imageries and all the survey details and all. So to manage the informations, we use these Bentley applications to develop the entire smart city project. And this is the one aspect of it. That is the initial plan was use the tool that is geospatial analysis. So we have done multiple works in terms of your area analysis and your land acquisition process and your the different map creations to submit to the clients and government, to the stakeholders to take the decisions easily, right? And use the MX road for different cross-section, different ROWs to identify the interface checkings, to identify the classes, and the quantification and your junction improvement. So this is one example of your typical cross-section. And also you used the water gems for water network design. So that is reduce the diameter with the help of zoning system. So what we did is before we start the projects, we sit with the consultants, with the stakeholders. So what would be the best case to define the network systems for the water network, right? So we created the zoning systems and the create a platform kind of gravity networks and drain the to create a pipe networks and all. Similarly, the second case was, these are for a few examples. And this is StormCAD we used in Dholera for storm drain water networks. So this is the enhancement we have done so far in StormCAD and saved the $65 million rupees. Sorry, 65 US dollars. Yeah. $1 million. So I'll pass to Jugal. So yeah, thank you.
Thank you. So all these applications which we were using, so it was there's a host of Bentley applications and few others, and all of that information had to be managed. So we have a project management information system implemented of which is ProLions. And we also have ProjectWise implemented in here, where all the document workflow was managed. So all the design engineering documents are hosted within ProjectWise, and all the transmittals were routed through ProLions. And that is what we're working on a dashboard to help the client understand and appreciate the status of the project. And also all the BIM models, all the I models, everything is being hosted within ProjectWise. We also enabled the geospatial interface, considering the scale of the project, which is 920 square kilometers. Obviously, finding the right document would be a challenge. So we understand that, and for it to be future-proof, we have enabled this geospatial extension for ProjectWise, so that we can go into a location, and then based on the zones they're working on, the contractors would find it easier to locate those documents. As far as interoperability and information mobility is concerned, we had to map out the entire information flow in terms of who's creating what documents, what's the format, and how that information flow works in. So in this, you would see that there are several different formats from an engineering standpoint which existed, but then we rationalized it to I models as the exchange format for BIM for design reviews, and shape files for GIS. So all of that information was extracted from there. And also for visualization, we brought things into SQLite to again future-proof that information. So we have the same information in multiple platforms, so that like the client is comfortable consuming GIS information, so they would use GIS information. The design team would use the 3D models to do design reviews and clash detection. So the engineers, when they started off, they actually created zones and corridors. So they said, okay, my sewerage will go from this, my water would go from here. And then when we asked those guys to come give their models, they were pretty confident and says each of them had done their job pretty well done. We brought everything together and we did clash detection in Navigator. We identified 2,000 clashes, which is expected, right, in that scale. But then the implication of that was that we had to get them to fix it because it had an implication on the project construction cost. So we fixed that, all that issues, and extensive use of each of these technologies. And the plan is to continue the innovation. So we are now going into a design and build stage, which is the next stage, and we want to continue this. So what we have done is, like, this is the first project in India where we have implemented GIS and BIM and project collaboration all together at this stage. Typically, the projects would leave it for the next stage, but we understood that the information model is very important at this stage. We've also created detailed BIM specifications and incorporated in the design and build contracts. So every contractor would need to deliver BIM and GIS, and we will be handing over these information models to them. So they would get direct access to ProjectWise, so they can start with the digital information and not reinvent the wheel. We also integrated GIS and BIM for this because we had all that information available. And what we're trying to do is create a workflow and technology platform and establish best practices for not just the next phases of this project, but also the next projects. And we have learned significantly from this project and several other projects within AECOM that we are kind of implementing this. The next phase in the EPC contract, when it starts, the plan is to integrate ProjectWise with the document control system and implement BS 1192 as a workflow, and also initiate asset management strategy for that. And as we say, we want to lead this smart city initiative, and Dholera would be a sample project for that. And we want to ensure that we do the right thing. So we have created a roadmap, but we are still flexible and we still want to evolve and improve it. And there's a plan to upgrade the supply chain with this. So when this is done, we would have over 10,000 engineers who would be BIM and GIS enabled.
Thank you.